Hello, and welcome to the latest episode of the ReAutomated podcast. Today, we are joined by Albane Dersy, who is co-founder and COO of French company InBolt, specializing in using AI to locate moving parts on automotive manufacturing floors. Albane is responsible for specification, implementation, and support of her company's product Guide Now, which has seen great success in automotive companies by reducing the amount of fixturing and work holding needed for robots. Albane, thank you for joining.
Thank you for the invitation.
So, Albane, how do you see the role of AI evolving in modern manufacturing environments, particularly in the automotive industry?
Well, it's been a complete change from 5 years ago until today. Now, customers are actually happy about having AI on their production line and promoting it internally and externally. 5 years ago was a completely different story. But I think what really changed is that now people know what are the benefits brought by AI. And these are benefits that they really require, which are more flexibility, so more intelligence to the robot, and an easier access to robot programming. And these are two things that AI is making possible that also reduces the cost of automation. So in the automotive industry, that's ultimately what they're looking for.
Fantastic. And can you share some more specifics about how this flexibility and improvements in efficiency are coming through the AI technologies that are now available?
Yeah, so there is two things. There on one side there is during the programming, and on the other side is during the runtime. And during runtime, the flexibility will come from computer vision, like vision sensors, 2D cameras, 3D cameras, and we will have AI-based algorithm that will analyze data from these sensors. How you use these sensors to improve the flexibility in manufacturing is to enable robots to work in what we call unconstrained environment. So an environment that is not typically made for machines who are traditionally used to do the same thing the same way every day, but rather for environments that are made for people, for workers. And this is what we need to automate right now. Customers were used to build factories around production lines 30 years ago. This is the pictures that we all have in mind, the body in white lines and like 30 robots on each side. That's not
Yeah.
possible anymore. Now you can't build another factory. You have to do more with less, and thus trying to automate what wasn't impossible before, but now you can do it thanks to AI and the intelligence that it provides to robots.
I think people our age probably remember Super Bowl commercials from like 2004 esque of the Ford commercials, the large, not a human in sight, robots swooping in to a very structured environment. So,
Yeah.
can you said unstructured environments? Can you explain a little bit? We've heard this word of unstructured versus structured. Can you explain a little bit what that is and why that's important for automotive companies in particular?
Yeah, so structured environment is when you know that the car is going to come at the same position, the same way every time in front of the robot. This is guaranteed thanks to jigs, indexing systems, fixtures, tooling that are usually custom made, not just like mechanical parts that are really maintaining and constraining the robot and the part. This constraining of the environment also comes with the cells, the cells and the around the robot that will protect it from people or from other things happening outside in the factory.
Mhm.
An unconstrained environment is a type of environment in which we navigate every day. It's an environment in which my cup that I have here can be either this way or this way on the table, but I will still manage to pick it up. Because if you want to automate that cup picking process in a constrained environment, you would need to, well, have a jig to really hold it at the same position every time. That jig will be custom made for this specific cup. But in my factory, I have 30 different cups. I can't afford to do 30 different jigs and change every day. I need to work in the same unconstrained environment as a worker would do, as I am currently doing. So this is the kind of unconstrained. We can also talk about unplanned environments, which is an environment in which you have some unplanned events coming in at the station, or that are not previously or human coming in next to the robot. Something that is also an unconstrained and unplanned environment, especially in automotive factories, are moving assembly lines. Moving
Mm.
assembly lines are, well, the definition of automotive manufacturing is the key for productivity. These are the engines moving, is the car is moving continuously. This is an environment that is typically made to enhance human productivity, but impossible to automate. You have no idea how the car is going to be. You can't track it. A robot can't adapt to the position of the car. And this is a type of environment that is, by definition, unplanned and unconstrained, but that you need to automate if you really want to improve your productivity as an automotive OEM.
That's great. And Albane, can you give an example of an application that your product guide now, with its AI powered technology, has been successful in the automotive environment?
Yes, so we developed, as you said, Guy Now, which is a combination of hardware and software. So it's based on a 3D camera that we mount directly on the robot, and an AI powered software that will analyze the data from this camera at a very high frequency to identify the position and orientation of a part, let's say an engine, relatively to the robot, and then realign the trajectory of the robot in real time according to how the part is moving. What our solution enables right now is the automation of such moving assembly lines, which are now possible to automate by just wheeling a robot and a camera and, let's say, a tightening tool, and
Mm,
perform a engine tightening process where it used to be not possible.
very good. And why have you chosen to use collaborative robots together with your AI powered solutions?
We're talking about environments like production lines, final assembly lines, which are 100% manual. Don't be fooled. The automotive industry is highly automated, but when you go into a factory, most of the production tooling you see are people and not robots. So all the lines on which we work in, on which we implement our solution to automate moving operations in moving, are actually lines in which you have people on one side and the other side of the robot. So if you want to be able to automate, you have to use a cobot that will be able to stop and go into a safety mode whenever there is a worker nearby. This is really the key element, I think, about automating moving assembly lines.
Very interesting. So I know from personal experience as well. AI is sometimes seen as kind of unreliable. I think many have experienced ChatGPT's hallucinations where the model is like confidently incorrect. So, how do you ensure at InBolt that you have reliability with artificial intelligence in your solution in automotive companies where they need to be sure that things are going to work? They have very low tolerance for scrap and for failures.
Yeah. Well, we do have what we call a hybrid approach. So on the one side, so the way you program our system, the only data that you need as an end user is a CAD model of the part that we need to locate and track. So the way that you would use our solution is by uploading this CAD model into our software that will automatically train an algorithm on this CAD model. And this kind of automatic training, this is what is powered by AI. There is no input, no fine tuning, no parameter tuning by the end user on the programming of this algorithm. And then during the runtime, this is where we use a deterministic approach. So during the runtime, whenever the part comes into the field of view of the camera, we can guarantee, according to a certain what we call heat map, that we can detect it at 100% reliability, or if it's a bit further, it's 99 or 95% reliability. So we can actually guarantee in certain conditions 100% reliability of our product during runtime for the end customer.
Very interesting. I've heard that heat map. I've read your website and some of your literature before. Can you explain a little bit more about what is a reliability heat map so that you can paint a bit of a picture for us?
Yeah, so whenever you have what we call a unconstrained environment, you need to, and whenever you have to locate a part, you need to know whether or not you're, well, either locating it right or you're not locating it at all, right? So you need to have that kind of like safety data, safety configuration that you send to the robot. You can't send false positive all the time. It's absolutely not possible, unthinkable on production line. What we have at InBolt is, according to how the part will enter the field of view of the robot, so according to its position and orientation, we will detect it. So, which means we will match the 3D data from the point clouds from the 3D camera with the CAD model of the part with 100% confidence, or we will, there are sometimes with like if it's coming a bit further away that in 5% of the case we won't match it, but in 95% of the cases we will match it. It's just a matter of like having a threshold in which we know that we can with certainty locate the part, or in some cases not locate it. But it's always about having a yes or a no. It's not about sending fake data to the robot. That's absolutely not possible.
So I imagine kind of a 2D, almost normally distributed, where the center is kind of green, and
Mhm.
then the edges are maybe red. And if you're fastening on something and the car is coming by, I imagine that if the car is coming by and it lines right up in the middle of the heat map in the green part, then you're very confident that it will be good.
And then no, it's not, we're not very confident, is we know we're going to locate it. If
Great.
the car is coming in like I'd say like 50 centimeters away from this green square, then if it's always the case, like 100 times it comes 50 centimeters away, then in 5% of the cases we won't locate it. But it is also important to know what are the conditions in which you will locate it for sure, and what are the conditions you won't locate it, so that not only you say it's a white and black decision, but also you know why. And the reason
Yes.
why is because it was too far away. That's
Yeah,
it.
interesting. So it's also the Z, it's the depth as well, and that allows
Yeah.
manufacturing engineers to design,
Mhm.
their specifications, such, right?
Exactly. And it's actually the same on the production line. These are cases that are actually rarely happen. In most of the case, whenever we program a system, we always deliver a system that for customers will work at 100% reliability, because in such industries, I mean, you have a certain types of big OEMs, and customer success is the most important thing that you can ever think of.
Very good. So pivoting a bit, let's look a bit at the future. So, can you provide an example of a breakthrough or innovation in AI for robotics that you find particularly inspiring or impactful?
Yeah, I think that what we're saying for AI and robotics are, so AI and robotics is a bit tricky because something that AI uses a lot are data set, right? And for a few years ago, we didn't have data set in robotics.
Yeah.
Who could have it? What we're seeing right now is the emergence of these data set that are being collected and like created over the years. And I think Covariant is a very good example of that, having
Mm.
created this huge data set from all the data from all the robots around the world to enable this kind of like easy off the shelf solution for autonomous robots for pick and place in certain industries. That's a great thing that we're definitely looking, and I think has a great potential in some types of industries like warehouse or e-commerce fulfillment. This is huge potential. On the other side, in terms of like AI, what we're seeing is the type of like technology bricks are becoming increasingly accessible to the end customers, who will be able to not only have great performance out of it but also learn how to use it. It's not only AI now, it's not only like in the dark corner for R&D,
Mm.
it's now in a product stage. Like how can you implement it within your existing product using the foundation models that other companies like Nvidia, for instance, are creating.
Yeah, very interesting. So there's more, proprietary data that's really coming to light to be able to train these foundation models.
Yeah,
And at the same time, AI is becoming more accessible to more people to be able to use.
exactly.
Very interesting. Yeah, I've read about NVIDIA's foundation model. They call it Groot, for example. It's based on humanoids. And I agree that I think some of the challenges may be getting enough data for it to compare it to something like GPT.
Mhm.
GPT 4.0 is trained on billions of parameters. They say kind of the size of the internet.
Mhm.
So it's going to take a lot of data to be able to get to that same level in robotics.
Yes, but we're still at the very beginning, but we're seeing like great growth and a lot of like momentum around it. Not only like the tech people, tech companies, robotics companies are really like on the lookout, but also the end customers are super enthusiastic, and that's incredible from what we're seeing. I think indeed, like Nvidia's group model is very interesting, and humanoids have definitely a great potential in household, for instance, or for services, or for just
Mm.
like going from point A to point B, where it might be easier to have access to this kind of data to really make the robot move around for navigation, rather than just for complex tasks that are usually jobs like welding or tightening, for which for now, it's still really complicated to have data access to.
Yeah, more in the home than in industry, even. Yeah. So, is there a subset that you're particularly excited about? I'll give you the analogy. So, in GPT, it empowers so many different things. They talk about law, they talk about healthcare, they talk about all these different things that large language models might be able to help with in the future. For robotics, with the possibility of a foundation model, is there a particular subset of things that you're excited about?
What I'm really excited about is how to make programming easier. And I think this is something that is one of the easiest and like short-term application of foundation models or LLMs is really how to make, because robots have all different programming languages. They all like this different approaches to like how to control joints and path planning, and having this kind of like more uniform but also simpler architecture to use as an end user would be great to really boost the adoption of robotics in the world. Because even if we see all these big names in robotics and the huge growth in robot adoption, we're still at the very beginning. There are new companies, new created every day, new needs identified every day. It's unthinkable what's happening right now.
Yeah, we talk a lot at Universal Robots with our new partnership with NVIDIA about being cognitively collaborative. And I think there's still a onus on people using robots to kind of put themselves in the shoes of the robot. Even when AI is in the application, you still kind of have to think in this linear, logical thing that, some people just don't think that way. There's a lot of different ways that humans think. And so I think it's really exciting in the future that there's the possibility of being able to be more cognitively collaborative and having the robots meet the humans where they are,
Yes,
less
whenever
so than
yeah,
them,
whenever logic is involved, this is will be game changing for the future for sure.
Yeah. And then my personal favorite thing that I'm really interested about is manipulation and grasping,
Oh yeah.
because, I call it the last inch. They talk about the last mile delivery and logistics a lot,
Mhm.
but the last inch, I think, in the contact between parts and robots and that interface is really exciting. I think that will have some great advancements with some of these foundation models.
Yes, that's definitely that is the key, and there is so many things behind that. It's not only like the robot and the robot control, not only the grasp point identification, but it's also the end effector and like the control of everything, simulation of everything. So when we talk about robotics, sometimes people stop at the six-axis robot. It's not. It's so much more, and this is what you're showcasing at Universal Robot with the ecosystem that you've kind of like understood rather fast, is that it's not only a six-axis robot. It's everything is intertwined. Whenever you go to a customer, you never go by yourself. You go with a robot manufacturer, you go with the integrator, you go with a vision system provider. And all this small village is making something happen that will work 100% of the time.
Yeah, beautifully put. Yeah. So, any final words on future trends towards the idea of how industries can prepare for this rapid advancement in AI and robotics in order to stay competitive?
Well, and I will talk just about the manufacturing industry because this is really my basic and my biggest understanding of the market right now is the manufacturing industry has a ton of data. Let's say they all have the 3D models of their parts, and all these 3D models of the parts they are manufacturing are great basis for having synthetic training about. It's just a synthetic data, and you can train algorithm on that data on how to better locate a part or how to detect a grasp point or how to do a lot of different things. So they have to make sure that they can get access to that data, but also capitalize it and use it for people providing, like us, vision systems for robot guidance. But
And
also, what
and
I
data, Albane, exactly what do you mean? Do you mean pictures
CAD
or
models. We only need 3D models, and this data already exists. It's an incredible thing that the industry, the manufacturing industry, has access to, which is the digital continuity from design to manufacturing. And we're currently seeing the gap in between the two, from this conception to production, narrowing down because we are using in the production the exact same data, which are CAD models, 3D models of what they're using for conception.
Very interesting. Very great. Thank you. I'd like to spend our last few minutes together talking about you as an individual, because I think you've recently won an award about being a strong leader and woman in technology. So I'd like you to please share some of your personal experiences and insights as a woman who is navigating the field of robotics and artificial intelligence.
Yeah, so I launched InBolt with two co-founders a few years ago, and we do indeed have a very deep tech products in AI, robotics, and most of it in the manufacturing industry. I travel all the time to every country in Europe and the in North America to visit factories to meet with customers. And it is true that we are in an industry and in an area where we have more men than women. That's a fact. And there is many days in my life where I don't see a lot of women. But this is something that is also changing a lot. Something that I've been able to see is that the automotive industry is very international. So every company is has like factories all over the world. So they had this incredibly diverse culture in each of these OEMs. And I'm seeing an increasingly big number of people, of women, heading factories, heading production sites, heading teams, and discussing with me and collaborating together on transforming how manufacturing is done today.
Fantastic. And what do you think are some of the key factors to help increase the representation of women in the field? Is there something there?
Well, of course, it comes to we have different scale of making that possible. What we're really focusing at on InBolt is having that representation within our own company, which is super super important. So we always try to look for the women because there's always a gap in between the number of applicants between men and women. So we have to look for the women extensively and to be able to at least interview them. That's super super important. Also, I think visibility is key, and there is an incredible number of events, opportunities, awards, as I just recently received, to really promote women on the stage, put the spotlight on them, and give them I would say, a mic like today to express their ideas, not only about what it is being a woman, but about their business, about what they do, like the company they're building, which I think is a great, and they're also their insights on the industry, which I think is a great way to definitely promote visibility for women. And then, yeah, I mean, the it's also about fostering STEM among young girls. It's STEM education is so important. I'm not an
Yeah, my,
engineer
my
myself.
sister's an art teacher and she talks about STEAM now, which
Oh,
is the inclusion of the A in STEM. So trying to
oh,
bring in kids who are, or children who are traditionally a little bit more artistic, there are ways to bridge that gap to STEM as well. I think, CADing, CAD,
yeah,
making CAD models is like a
yeah.
fantastic, or digital drawing and design in general. Typically it's a pretty right and left brain thing, right? So
Mhm.
that's a good example maybe as well.
That's definitely something that you see a lot in architecture as well, like 3D design, all that kind of thing.
Right.
But I think I'm not an engineer myself. I have no background in like mathematics or physics or computer vision, and but a lot of my customers think I'm an engineer. It's just because I started my career at InBolt by asking just so many questions. And if you never ask questions, you never get the answers. And sometimes the answer is just so simple, and the questions are also so simple to ask. So I think that's also a great way to gain knowledge, gain expertise, and also realizing that even your customers or even the people you think have the answers sometimes don't have them.
Maybe that's the same answer that I'll ask to my final question for you. But what advice would you give to young women who are interested in pursuing a career in robotics and AI?
Well, it's probably yes. It is going to be the same answer. It is going to be asking questions. Everything is simpler than you think it is. In the end, it's just about making a product that answers the customer needs. So if you go from there, which our customer needs, we all have common sense to really understand them, and it's then going backwards to build the best product possible. But you really have to start from the customer itself, and the needs are usually very, very simple.
Fantastic. Albane, I could listen to you talk all day. I think you are one of the most cogent guests we've had who have been able to come in and explain AI in practical terms. So I'm really excited to see this podcast episode get launched. Thank you very much for joining us.
Thank you. Thank you for having me.
And once again, this was the ReAutomated podcast. Albane is the co-founder and COO of French company InBolt, who is specializing in using AI to locate moving parts on automotive manufacturing floors. We'll see you again soon.